Hi everyone. This should be actually a really quick and easy lesson, especially since you've already done the lesson on the factor theorem. This is really not much in terms of what you need to know about polynomials. But this is section 11.4, estimating solutions to polynomial equations. A lot of it goes into ways to use your calculator and some calculator functions. So you will probably want to have a calculator handy that you can be trying these things along with me. Okay? So we're just going to dive into an example here. So I've got a crazy function, and I want to know what value of x would make this function come out to equal 4. That's what this is saying. I want f of x, which is this whole thing, to equal 4. So this first question says use a graph in our calculator to just determine how many solutions, how many values of x could there be that would make this thing equal to 4. So let's talk through how to do that. We're going to go into our y equals, okay? And I'm going to type in this equation here, 4x cubed. Oh, you know what? I remember this one from last year. I apologize. This should actually be a 4x to the 4th, because otherwise we would have a 4x cubed and a 3x cubed. So 4x to the 4th. Sorry for not catching that before. Minus 3x cubed plus 5x squared plus x minus 5. And I'm going to hit zoom and number 6. Okay, zoom 6 to reset my window from whatever other crazy stuff I may have done. Okay? And so here I can kind of see this function. What I might do now, just to zoom in a little bit, I see I have a lot of empty space over here and over here. Okay, so I'm going to go to my window and I'm actually going to close my x's in a little bit. I'm going to go -5 up to 5 and hit graph. And that might just give me a little better picture of what's going on here. Okay, looks a lot like a parabola actually. And then what I'll do is I will go back to my y equals, go to my second y value, so y2, and just type in a 4. So this really works anytime you're trying to get one equation to equal another, is you can type 1 into y1, 1 into y2, and then hit graph. And the solutions that we're looking for are these two right here. I want to know what x values are these that would make these two things equal. Okay? But to answer this first question, I just want to know how many solutions do I see? I see 2 solutions. Okay? Then it says use the table to determine the consecutive integers between which the solutions fall. Okay? So now I'm going to look at my table. And what I'm looking for, so the reason this is all 4s is this comes from that second section, right? But I want to see where this y1 is close to 4, okay? And gosh, it falls right in here. So, and I know this jumps really quickly, but see here between 2 and 57, obviously I would have a value of 4 in there somewhere, between 2 and 57. So x-wise, I would say one of my solutions falls between 1 and 2, okay? Because my graph from 2 to 57 obviously is going to cross over where y is equal to 4. And then let's look and see if we can find where it would happen again. Oh, probably right there. So again, between -5 and 6, I cross over y equals 4. So between 0 and -1, I must have a solution. Okay, so that's what that means when it says find where it's in between, is look for where do you cross the 4? Where would your y values have to include a 4? And we could actually break our table down to like decimal points here and get a little bit closer to 4, but we just want to know where would we cross that line. Okay, and if I look at my graph again, this one here does appear to be between 0 and -1, a lot closer to -1, but it's between 0 and -1. And this one is just past the 1, so this would be between 1 and 2. Okay, so I found how many there were, right? And then it asked me to be a little more specific and say where they were located in general. And I said it's between this and this. Now I want to find what those solutions actually are. Okay? And so to do that, I'm going to use something called the intersect function. And you may want to watch me do this and then pause the video and try it yourself. But I'm going to go to the calc menu up above trace. I'm going to choose intersect, option number 5. And then see how my cursor is on that first curve there? I'm going to just move it to the left so that it's a little bit closer to that intersection point. Okay, you just want it to make sure that you're closer to one than the other, because otherwise your calculator gets confused. So I'm going to just move it right there and say enter. That's me saying yes, this is the first graph I want you to look at. Now my cursor has jumped to my second graph. So I'm going to hit enter again to confirm that this is the second curve I want to look at. And then when it says guess, I just hit enter one more time. And it tells me one of my solutions, I'm looking at the x value there, is at negative 0.937. Okay? And that means if I was to plug negative 0.937 into this function, it should come out to equal 4 or awfully close to 4 because of your decimals. Okay, that's great. And that's my one that would be between 0 and negative 1, right? Now I need to go find the other one. So I'm going to repeat. I'm going to go second calc, intersect, option number 5. This time I'm going to move my cursor to the right to get it closer to that other intersection point. Okay, so like there's good. Hit enter. Second curve, yes, that's the second one. Enter, and then guess one more time. And I get 1.0, well, I guess I would round to 1.1. And again, that would be my one that's between 1 and 2. Okay, so that's just some ways that you could use the calculator. There is one more thing that you could do. So it would kind of all work along these lines too. But this original function, if I had it set equal to 4, like that, so kind of ignore the f of x, pretend I just had all of this equal to 4, I could go ahead and subtract 4 from each side. And so then I would actually have the equation 4x to the 4th minus 3x cubed plus 5x squared plus x, and then negative 5 minus 4 would give me negative 9 equal to 0. And then when I graph it, I don't have to mess around with having 2 lines. Okay, clear this out. I could type that in. Oh, I should have left that, but 4x to the 4th minus 3x cubed, whoops, plus 5x squared plus x minus 9 this time. Now my graph is going to look different because I changed my polynomial here. But now what I'm looking for are the zeros, right? Because I moved that 4 to the other side, so now I'm looking for where does this thing equal to 0. So I would still say that it hits the it hits the x-axis twice, okay? I could still use my table, except this time in my table what I'd be looking for is where do I cross from positive to negative? Because crossing from positive to negative means that I pass 0, okay? So like again, between 0 and negative 1, you'll see I went from positive 2 down to negative 9. So I must have a 0 in between there. And then between 1 and 2, I jumped from negative 2 to 53. So I must have crossed 0 in between there too. Okay, so if you don't like using the 2 different equations, if you don't like using the 2 different tables, you can always set everything equal to 0 and solve it that way as well. Which I think is kind of what example 2 is getting us into. And notice the big key word here in example 2 is estimate. All right, that's going to free us up a lot. But let's go ahead to our calculator. 3x to the 6th minus 8x to the 4th plus 2x squared plus 3. And then again, I'm going to reset my window, zoom 6, just to make sure I'm seeing the whole picture here. Ooh, kind of a lot going on there. Okay, I may now, and I always reset my window so that I can get kind of a big picture, but now I'm going to shrink it again. I'm going to make my x's go from negative 5 to 5. And that'll just shrink how much of the x-axis I'm seeing so that maybe I can see where these are at. Okay, it appears to be symmetrical, which is nice. It looks to me like I have roots right at positive 1 and negative 1. And then I just have to kind of estimate where this would be. If this is 0 and this is 1 here, am I too far for 1? Let's see. Let me just do this real quick. Okay, so actually these ones at the curve are at 1. I knew one of them crossed right through 1. So these ones that are kind of on the downward curve, those are at 1 and -1. I need to estimate where these are at. It's going to be between 1 and 2, and it looks kind of close to the middle, so I might be willing to say about -1.5 and about +1.5. Okay? But estimating from the calculator is really just kind of counting your dots and approximating. Okay? We could look at our table to see for sure. So yeah, right here. See how these are exactly equal to 0? That means that these two are exactly at 1 and -1. My other ones, though, I would have to really work with that table to get more exact. Okay, and there is a way to do that, but since this question just asks us to estimate, that's all we have to worry about. Okay, so a lot of this section is just going to be putting things into your calculator and using your calculator to find what you need. And if you need some help working with the calculator, please let me know. Okay, that's it for today. Homework for tonight then is going to be 11.4 and 11.5b, some lesson masters for you. Those are located in your packet.